So let me start the discussion. So can I start the discussion now? Can someone reply?
Yes, sir, we can start.
Thank you. The screen is visible now, no?
Yes, sir, visible.
Yes, thank you. Myself, Suraj Pri, from Chemical Engineering Department, IIT Kharagpur. I am a research scholar. I am here to deliver previous year NPTEL assignment solution for the course Principles and Practices of Process Equipment and Plant Design. This is the first question in which we are asked to match column 1 with column 2. In column 1, unit operation, unit process and industrial process is given. In column 2, some examples are given. So we know that unit operation is a physical process. So out of this, can someone tell which one will be unit operation? From A to C.
Production of kerosene in petroleum. Production of kerosene in petroleum refinery is the unit operation.
Yes.
Unit process is the reaction of magnesium metal to form phase change in the first. Second we can match with
Second match with
And third the heat exchanger between hot and cool fluid in the industrial process.
can you give an example of industrial process? Hello?
The production of kerosene in petroleum refinery is an industrial process.
Yes. Yes, and unit operation is heat exchange between hot and cold fluid in heat exchanger. Unit process is some chemical reaction involves in between that operation, so it is called as unit process. So reaction of magnesium metal and oxygen to form MgO2 is in a chemical reactor. It's an example of unit process. So 1 will be C, 2 will be A, and 3 will be B. These are the these are the definitions of unit operation. Unit operation involves only physical changes in the system. Unit process involves some chemical reaction. Industrial process converts feed material to useful product of desired quality. These are some examples of unit operation. Let us say absorption is a unit operation in which we are adding solvent to the gas stream to absorb some of the component in the gas stream. An example of absorption is if we want to remove from hydrocarbon mixture hydrogen sulfide and CO2 from hydrocarbon mixture, we can use diethanolamine as a solvent. Here is the schematic of that. Sour gas is the hydrocarbon mixture that is contaminated with hydrogen sulfide. So we will pass diethanolamine from the top. It is pumped from the top, and it gets contacted with hydrocarbon mixture containing H2S. This H2S will be gone to diethanolamine, and it will be collected from the bottom. Sweet gas is the gas which is free of hydrogen sulfide. So after absorption, we will obtain sweet gas. The next is distillation. Distillation involves use of heat to purify the mixture of components. For example, here also we can see the example of distillation. The diethanolamine which is contaminated with H2S is purified using amine regenerator. Amine regenerator is a distillation column. It's a distillation operations. Next is extraction. In extraction, if a mixture of components with mixture of miscible components are present, then we will add some third component which is called as solvent, which is only partially miscible with one of the component and completely miscible with other component. So in refinery, sulfonine is used to extract benzene, toluene and xylene from naphtha reformate. This sulfonine is miscible with benzene, toluene and xylene, but immiscible with naphtha reformate. Next is adsorption. Adsorption involves the use of adsorbent, which is a solid material. If we need to separate the one of the component from a gas mixture, we can use we can contact it with a solid substance called as adsorbent. Removal of moisture from air by alumina for instrument air purpose is an example of adsorption. The instrument air used in industry, instrument air is used mainly for controlling the control valve. It is supplied at the top of the control valve. It is at pressure of 3 to 15 psig. So it should be free of moisture in order to prevent the corrosion of diaphragm present in the control valve. So this moisture is removed by using alumina or zeolite in a packed bed adsorber. This is an example of industrial process. Here we can see that crude oil is coming from storage tank is desalted using desalter. Desalting is required to prevent the fouling of the tubes present in the downstream. If salt is present in the crude, then it will cause corrosion and fouling of tubes in heat exchanger. So after desalting, we will pass it to furnace, then we can collect the fraction of components from the distillation column. This is an atmospheric operated distillation column. The residue will be next passed to vacuum operated distillation column. So here kerosene is recovered and it is known as an industrial process. So first question is over, then we can move to next question. Question number 2. Batch process is preferred over continuous process because can someone tell the answer of this?
Greater
So
control
all
on
of the
process.
above. All of the above.
Okay. Yes, all of the above. We know that batch process have some benefits because they are economical for small reaction volumes and they are flexible in operation, as we can change the product formulation with our wish. Then if we need some regular cleaning or sterilization caused by fouling, we can use batch operation. And if some product in a particular batch is contaminated due to our operational failure, we can discharge that to slope, or we can pass into slope. So only one batch will be damaged, remaining batch will not be contaminated. So that's the difference between main difference between batch and continuous operation. If some operational changes occur in continuous process, then the whole product will be affected by it. But in batch process, as it is done in batch mode, if some particular operation parameter is changed, then only that batch will be damaged. Other batch will not be affected. But batch processes are relatively sensitive to operational condition. If the operational condition changes by a little bit, like if temperature exceeds by 10 degrees Celsius, the yield of the product might not be as per our requirement. This is a simple schematic of batch reactor. This is a stir batch reactor. Like initially we will pass the feed which need to process the reactants that we need to process using from a storage tank using a pump which is preheated using a heat exchanger. It will be then dumped into a batch reactor. Then after reaction happens, we will hold it for a particular time for the reaction to happen by supplying heat with help of steam. In some cases we may use cooling for we might need cooling water if the reaction is exothermic. If in some cases we might need heating with steam for endothermic reactions. So after the reaction is over, we will empty the reactor with help of a pump. And the products will be stored in storage tank. So this is a schematic of batch reactor. So next question, if the partial pressure of component in an ideal solution is 1000 Pascal and its vapor pressure is 2000 Pascal, then what will be the mole fraction of component in the mixture? Here we can use, as it is an ideal solution, we can use the equation of Raoult's law, not Raoult's law. Can someone say the equation of Raoult's law? Hello? Hello? Hello, can someone reply? Hello?
Partial pressure to the total pressure.
What partial pressure, total pressure related by a different law, Dalton's law. Like sum of partial pressure is equal to total pressure. But I was asking about Raoult's law. Raoult's law for ideal solution.
Partial pressure to the vapor pressure.
Yes, yes. Partial pressure and vapor pressure are related as partial pressure is equal to mole fraction into vapor pressure of that component. So here partial pressure is given as 1000 Pascal, vapor pressure is 2000 Pascal, so mole fraction will be equal to 0.5. And option A, B and C can never happen because can someone say why option A, B and C can never happen?
Because it is a fraction. Fraction are not above the 1.
Yes, good.
Mole fraction will never be above 1.
Yes, okay, good. So the answer is 0.5. 1000 by 2000, answer is 0.5. Here the partial pressure is 1000, vapor pressure is 2000. On substitution we will get mole fraction as 0.5. So next question, the size of a distillation column is determined by a rate of mass transfer between phases. Can someone please tell the answer for this?
Number of components.
No.
Then all of the above.
No, not all of the above. It's rate of mass transfer between phases.
Will you please explain that?
Pardon? Hello, can you repeat?
Will you please explain that? The size of distillation.
Like the it's mainly affected because of rate of mass transfer between the phases. It's coming in the coming slides. Concept of efficiency and capacity of a separation process. Distillation is a separation process, and the efficiency of separation is mainly related to mass transfer and the product purity that we require. The capacity of a separation process is the rate of material which can be processed without a loss in efficiency. So if we need more capacity, then more the diameter of the column we require. Diameter of the distillation column we require.
Okay.
And the efficiency and capacity are interrelated. Adding an additional bed in series of a packed bed absorption process can increase the efficiency by increasing the absorption, but it can reduce the capacity. Capacity of a membrane process can be increased by increasing the size of a membrane pores, allowing more molecular species to pass quickly, but the pore size increase can lead to broader range of molecular species to pass through the membrane. With increase in capacity, the efficiency will decrease. So next question: which features are present in process flow diagram? In a process flow diagram, can you identify which all features are available? Can you please tell?
All of the
All
above.
of the above.
Okay. Then what will be present in process and instrumentation diagram? What will be the difference?
In process and instrument diagram, they have like control philosophy is also there in P&ID.
P&ID
We
is
can,
yeah,
wall is there.
valve is there, yes.
Yeah.
What only valve is present. Valve might be present here also. Anything other than that?
The temperature and pressure gauges.
Okay. Yes, so let us see what is process flow. Difference between process flow diagram and process and piping and instrumentation diagram. PFD show main equipment items, process flow, stream flow rates, temperature and pressure, which are sometimes represented in a table. A P&ID show all equipment, piping, pipe fittings, and control system. So they will give fittings also, pipe fittings and control system, like control valve loop. It also includes standby equipment and piping used during startup, shutdown, and maintenance. But these type of equipments are not shown in PFD. In P&IDs only. P&IDs are more complex, and it gives detailing of all the equipments present, including the startup and shutdown maintenance equipment. And some emergency instrumentation will also be given. For example, this DMDS is a sulfiding agent, dimethyl disulfiding. It is a chemical used to sulfide the catalyst by poisoning. So prior to the startup of a HDS unit, like hydrodesulfurization unit, we might need to poison the catalyst to decrease the activity. So we'll poison the catalyst with help of DMDS pump. This will be used only during the startup. So DMDS pump figure will present only in P&ID diagrams, but not in PFDs. And next one is KMNO4 wash pump. This potassium permanganate is used to prevent, after the shutdown of a plant, we will usually wash throughout the column and piping with help of potassium permanganate in order to prevent the contact of pyrophoric material present inside the column or tube with air. What will happen if pyrophoric? Can someone say what will happen if pyrophoric material get contacted with air? Air or oxygen?
Catches fire.
Okay, okay. It's- So it catches fire. So in order to prevent that, we will wash whole of the reactor scheme, reactor tubes, reactor piping, everything we will wash with KMNO4 and remove all the pyrophoric material. And this will be pyrophoric material is denoted by FES. When FES is contacted with oxygen, it will release heat by forming Fe2O3. So this when we contact FES with KMNO4, it will be converted to FeSO4. This FeSO4 is less active when compared to FES. Did you got this? Hello? Did you got what is KMNO4 wash? Did you understood it? Hello? Hello? Hello?
Yes.
Like, did you got what is mean by KMNO4 wash?
Yeah.
Okay. Then this some abnormal operation will also be present in P&IDs, like push button to trip equipment. So if we need if some fire have happened near to the furnace area, we can trip the furnace using one push button. So it will also be present in the P&ID diagram. And P&ID also show control scheme, identification number of the equipment, piping and control equipment. But P&ID may not show the information of process flows and conditions. The P&ID will vary from vendor to vendor. So these are the common symbols used in PFDs and P&IDs. Like in this fail safe and fail close positions are shown. Like this means if instrument air fails, the control valve will close. If instrument air fails, in this case control valve will open. So this is the fail safe and fail open position. Like this is the it will vary depending on the arrangement around the valve. These are the example of gate valve, globe valve. Globe valve is mainly used in controlling, and gate valve is only used for complete shutdown or complete open position. These are the figure of centrifugal pump, symbols of centrifugal pump. This is an example of PFDs. Here we have a storage tank. Here we have a storage tank in which some liquid is flowing. The liquid is a mixture of water, salt and sulfuric acid. It is pumped using a pump. What is this? Can someone tell what this representation means? Like after pump between 2 and 3, what is the symbol represented?
Heat exchanger.
Heat exchanger.
Okay, heat exchanger or condenser?
Condenser.
It's a heat exchanger. Like after pump, after this storage vessel, where it goes is to for storage. So before storage, we will cool it with using cooling water. So for same scheme, we can draw the P&ID. This is the P&ID for the same scheme. Here one, can someone say what is this representation? Just left side of the
Level transmitter.
Level indicator. Means
Okay,
Yes,
okay.
level indicator.
This level indicator, yes. Then hereby two pumps are given. So if one pump got tripped, then in that case we can use other pump. Like if
standby pump.
standby pump, yes. So this is the arrangement around pump. Just after the pump, we can see one non-return valve. This is a non-return valve.
Check wall, yeah.
Check
Non-written wall.
check valve. Uh, so if the this is to prevent the flow in opposite direction. If the flow is in opposite direction, it will damage the impeller. It will damage the impeller. So an NRV is present outside at the discharge of the centrifugal pump. After that, there is a globe valve, gate valves. Then this is the control valve. This control valve is not shown in PFD. Like if we don't need this control valve, we can bypass using a globe valve. So this is the this is the control valve loop in a P&ID. So if the this control valve loop contain a control valve, this is a gate valve. These two are gate valves, and this one is a globe valve. So usually, if control valve is in operation, we will not open the globe valve. It will be in complete closed position. But if we need during maintenance, we will off this line, close this line by closing the gate valve on both sides. If we need to isolate the control valve and take it for some maintenance, we'll close gate valve present in both sides. This is a bleeder valve. If some hydrocarbon is present in this line, we can bleed it out using a bleeder valve. So next question. Fill the column 3 of the following table with suitable separation process corresponding to single phase homogeneous feed mentioned in column 1 and means by which the second phase is created mentioned in column 2. In column 1, some single phase homogeneous feed is given. In column 2, some operation is given in which second phase is created. When liquid is suddenly, if some sudden pressure reduction happen to liquid, then the process is known as flash distillation. When liquid and liquid solvent are mixed, then it is known as
Extraction.
extraction. Not extraction, yes. Then
Extraction.
extraction. Then if solid and liquid get contacted, then it is called as
Adsorption.
Leaching, sir.
leaching.
AD. Adsorption.
No, absorption or adsorption.
AD. Adsorption.
Adsorption, okay. Adsorption happens with solid gas mainly, but it can happen reverse also. Solid liquid also. So liquid contacting with gas stream is called as, like I previously told, liquid contacting with gas stream is called as
Absorption, sir. Absorption. AB.
AB.
yes, absorption. So when a sudden pressure reduction in liquid happens, we will get it. Flash distillation will happen, but the flash distillation purity of the product of distillates obtained in the flash distillation will be low when compared to continuous distillation. Only two streams will be obtained at the top end. One will be rich in vapor phase, one will be rich in liquid phase. This is an example of schematic of flash distillation. This is the pressure reducing valve or throttling valve. Like question number 7. During optimization of any process, if the objective function is multivariate and it has dash solution, then one need to take dash consideration to obtain the design solution. Hello?
Yeah.
Multiple solutions.
Multiple solution, yes. Then question number 8. Choose the incorrect statement among the following. Like this one, can someone give the example of an objective function used in a process industry? For optimization of any process in process industry, can someone give example of objective function?
No.
Okay, like cost optimization of a heat exchanger, if we need to maximize or minimize the cost, it is an example of objective function. Like if in some
Minimizing the cost.
yes, minimizing the cost. So can you give some example of variables minimizing the cost of heat exchanger?
Pardon, sir.
If the objective function is minimizing the cost around a heat exchanger, then can someone gives example of variables involved in it?
Minimum heat exchanger area.
Okay. Yes. Then question number 8. Choose the incorrect statements among the following. Out of this, which are incorrect? They are asking which are incorrect.
None of the
All are correct.
All are correct. Yes. Then match column 1 with column 2. Like what is isometric drawing? An isometric drawing gives spatial location and routing details of every physical item in the plant.
Give special location details of your research.
Yes. Then fabrication drawing.
C is the answer, sir. C.
Then a plot plan.
D. Give relative location of equipment
Okay.
on a scale plan.
D is the answer, sir.
Okay. Then question number 10. Choose correct statement among the following.
Both statements are true.
Okay. Okay, so both statements are true. And design of a process plant involves both qualitative and quantitative consideration. Qualitative consideration are based on experience of the designer, and the quantitative consideration are based on mathematical analysis. So thank you all. If you have some doubts, can you please ask? our faculty, your faculty is also present here. Professor Esra sir is also present. You can ask him also. Hello, Ray sir, can you reply? If do someone have doubt? Hello, do you have any doubt?
Sir, can you give this presentation for future reference?
Yes, I can give. I will upload it in Google Drive. Hello, sir.
Yes.
Okay, can you reply to some of the queries?
Yes, I can. Okay.
Okay, sir. Okay, thank you.
What are the queries?
No, they might ask randomly, sir.
Fine. Then I'm okay. I'll be there.
Hello, if you have some queries, you can ask to Esra sir. Hello.
Unmute myself.
What? Hello.
Good afternoon, all of you.
Good afternoon, sir.
Good afternoon, sir.
Yeah.
Good afternoon, sir.
Yeah.
If you have some doubt, you can ask with him.
Sir, I have an query, sir.
Sure.
Sir, as you shown in the P&ID, there is a control valve and a bypass system. What would be
Right.
the best practice, the control valve sizing and the bypass valve sizing? If they are both are the same or different, sir?
I'll let me. Are you hearing me clearly? Can I respond now?
Yes, sir. Yes.
Fine. Okay. It's like this. We have not dealt about the sizing of the valves here in details, but if you're talking about control valve sizing, the process is finding out the valve factor CV. The valve factor CV, basically, you can say, is an indication of the size in an indirect way, in the sense it's the United States gallons per minute of flow through the valve when the pressure drop across the valve is 1 psi and the valve is 100% open. So if you, when you are sizing your control valve, you normally find out what will be the CV estimated, and you buy from the market a valve which has got higher than that particular CV value. In case of the valves that you see here, one is a bleeder valve which is perpendicular to the main line. The two are the isolation valves. These are gate valves to isolate the valve. Most of the cases, what you will find, your control valve physical size would be one size smaller than the line size. The line size, normally that's covered later on in one of your classes, is based on the pressure drop per unit length which is affordable in this particular service. The valve which is in parallel with the control valve is the globe valve. Normally, the globe valve will remain shut. All the flow regulation will be through the control valve opening, and quite naturally, the other two gate valves are only for isolating the control valve and sending it for maintenance. And during maintenance only, the globe valve will be used for regulations. So the sizing will be for the globe valve and the control valve will be very similar. But in most cases, you'll find a control valve size, the physical size. For example, if it's a 2.5-inch line, you'll be having a 2-inch control valve. That's what you'll find. But there are some cases in which on a 4-inch line, you can find a 4-inch control valve also. That depends on basically the pressure drop, which is affordable by the control valve. This is how you size the valves in such type of piping. I do not know whether you are satisfied with this or you would like to. If you are really interested in knowing more about it, you can get my email from our teaching assistant, Mr. Suraj can give you. We will definitely respond.
Okay, sir. Thank you.
Thank you. Other questions are welcome.
Sir, in one of the slides,
Yeah.
a solid was in contact with a solvent. So the answer to it was leaching. Why is it not extraction or absorption? Sorry, adsorption.
Adsorption. Okay, fine. I'll put it like this. By definition, in fact, it's an academic definition, definitely. Extraction is a liquid-liquid contacting process. When you take out one of the components, first, or some components, from one liquid to the other liquid phase, that is extraction. And definitely, Mr. Suraj has explained, comparable to leaching, you have solid liquid extraction. In most of the cases, it will be one or more component from the solid phase dissolving into a liquid, and that's equivalent to that liquid-liquid contacting. It's a solid liquid contacting. Mr. Suraj has also supplemented that yes, it is also possible to have solid adsorbent and a component which is transferred from the liquid phase to the solid, and the process is adsorption. That he mentioned, I have heard him saying so. An example of this is basically the removal of color from some effluent when it passes through a charcoal bed or an activated carbon bed. The coloring component gets adsorbed, AD, on the adsorbent, which is either charcoal or it could be activated carbon or it could be something else also. So you are absolutely correct. When we are talking about solid liquid contacting, the process in most of the cases, rather it's more common to have such contacting in cases of leaching, but in case of liquid solid adsorption also, yes, such contactings do happen.
Okay, thank you, sir.
Anything else or anything or any
Sir.
clarification? Yeah.
Yes. Sir, where we use flash distillation and where we use the conventional distillation?
This is something which is supposed to be covered under flash distillation. Doesn't matter. Normally, you will find that in case of flash distillation, the separation is only by a single stage of contact, vapor liquid contacting. That means we do not have many stages to purify or have a large difference in the composition of the top product and the bottom product. When this is sufficient for us, we go for flash distillation. I'll give you an example. The example is very simple. Suppose my gear oil gets there is someone here. Suppose I have a barrel of gear oil which gets contaminated with naphtha or petrol. The quantity is small. I have only 1% by volume of naphtha which has got contaminated my gear oil. Now what do? I really need the naphtha or the gasoline which has contaminated my heavy component to be separated. So in such cases, I don't need many stages of separation, and a flash distillation is good enough. So in most of the cases, when you are really not much concerned with the purity of your product, you are happy with a single stage of flash distillation. And one such example is basically removing of highly volatile contaminants from some heavy liquid. The example which I gave is gasoline contaminating lubricating oil. So this is the application of flash distillation, you can see.
Okay, sir. Okay, sir. Thank you. We may say that the boiling point difference between both binary systems far away, we may use flash distillation instead of conventional when we required it.
You're absolutely correct. Normally, you will find flash distillation being employed to remove more volatile, small quantity of more volatile component from a heavy material.
Okay, sir. Thank you.
And you do not really need high quality of purity. If you really require a high purity distillate, you definitely will have to go for more than one stage of vapor liquid contacting. That means you have to go for fractionation or something else. Not just simple flash distillation will help you. Well, we are awaiting other questions. Any of you, please feel free to ask any clarification or any other point that comes to your mind.
Hello, if nobody is having any query, we can leave the meeting. I will share the materials in Google Drive form. And I will share the S-Racer's mail ID also.
Right, I think that will be good. You shared Professor Gargidas and mine both.
Yes, sir, yes.
And yours as well, definitely.
Okay, sir.
Thank you, sir.
Okay, thank you.
Okay. If you have any
Thank you.
question, you can still ask. We have, 7 minutes more. Otherwise, we can, if you do not have any question, we can call it a day. I think people have started leaving. So, Mr. Suraj,
Okay, sir, I am exiting.
I think we can conclude the meeting now.
Okay, sir. Okay, thank you.
Thank you.
Thank you for attending.
Thank you.
Thank you, sir.
Thank you all.
Thank you, sir. Thank
Bye.
you, sir.